This is a short detail video about seeing why internal and external sieves are secretly the same thing. So I thought that I would do this just by expressing the translations. So I'll explain how you can go from an internal sieve to get an external sieve, and then I'll show how you can go from an external sieve and express it as an internal sieve. And these two processes will be kind of obviously inverse to one another. Okay, so just to recall the setup, an internal sieve is a collection, or an internal sieve on U, where U is as up here, is a certain collection of subobjects. And an external sieve on U is a subfunctor of H of U, the embedding of U under the, with the unit embedding. So let's go in this direction first. Let's go from an external sieve to an internal sieve. I'll do that first. So the only thing we have to remember here is kind of what our subobjects look like. So we just remember that HU of V is equal to the set with a single object if V is inside of U, and is equal to the empty set otherwise if V is not inside of U. So that tells us that for S as up here, we have that, so S of V is one of two things. Maybe I'll express this set theoretically. So S of V is either the single point set, or it's the empty set. And once we remember that, we can make this translation. Okay, so how should this translation from external to internal sieves work? Well, we start with an external sieve, so we've got some subobject of H of U, and we need to produce a collection of open subsets of U. So the way that we'll do this is just create the collection as follows. So we'll take the external, I'll just write it out like this actually. So we'll take this external sieve S and we'll map it to the set of all V inside of O of X such that S of V is equal to the single point set. That's how we go from an external sieve to an internal sieve. We take that external sieve and we map it to the set of all things for which the external sieve evaluated that object is not the empty set, it's the single point set. Okay, so let's go in the other direction now, from an internal sieve to an external sieve. And as is necessary, this will be inverse to this process. So we'll sort of just do exactly the same thing in reverse. So going in the other direction, we'll say, let's let S be that collection. So S is a certain collection of subobjects, right? It's an internal sieve. And we're going to map that collection of objects to a functor. And that functor will be the functor which takes the open set V to the single point set if V is inside of S, and to the empty set if V is not inside of S. Okay, and that's what the inverse translation will be. That's how we're going to go from here to here. Now there's some stuff to check in this which I'm not checking. So first of all, I've given this correspondence from an internal sieve to this alleged pre-sheaf, but I haven't actually checked that it's a pre-sheaf. So if one wanted to be thorough, one should actually check that this thing is a pre-sheaf. And in the other direction, we went from some pre-sheaf to some collection of subsets of U, but we didn't actually check that that collection of subsets satisfied the sieve property, that it was downwards closed. So to be complete, one would also check that. I'm not going to in either case, I'm just sort of clarifying that I didn't. But in any case, that's how the correspondence works, and that's why internal and external sieves are really one and the same.